Hi guys, my name's Paige Crawford, and I'm interested in being a ULA for Lockett 241. I was previously his ULA the last time he taught this class in fall 2024, and I loved working with Dr. Lockett. He was my 241 professor, and I just enjoyed being with him. So I think it'd be such a great opportunity to do it again as I go into my last year at Carolina. So why do I want to be a ULA? I just really enjoyed my experiences with my ULAs in 241, 251, and 430, and all the chem classes I've taken here at Carolina. I feel like they're so helpful, they're so knowledgeable about the material, and they really make my experience in the class a lot more manageable. And I want to be able to do that to other students. I plan on helping students by just giving them the tips and tricks that I use. While it may not be the correct, or not, I want to say correct, but or incorrect, it may not be the most scientific or chemistry way of explaining things. I think sometimes it does help to have these like mental shortcuts or mental ways of thinking about things that isn't maybe exactly correct, but helps students get the work done and get the point across. And it's just different ways of thinking about things. And I think that's something I can bring because I know for a fact everything, the ways I think about things aren't the exact way all the time, but they do help solve the problem, if that makes sense. But going into how I would help a student, so I kind of worked out a problem already, and I'm just going to explain my steps of how I did that and how I would explain this to a student. We're only going to do question A because of time, but okay. So we have this question here, and it's asking us to determine the predominant charge of each of these amino acids at a pH of 10. So going back to the question, if we read the question first, because we don't want to just jump to part A, part B. Sometimes that there's information that we need within the question. So looking at this question, we're told that we're trying to separate amino acids and that the only thing we have left in the lab is this cation exchange column. So I would start by asking a student, what is a cation exchange? What do you know about a cation exchange column? And listen for their answers, help guide them through it. But basically, what I'm looking for in their answer is that they understand that in a cation exchange column, we have a negatively charged stationary phase that allows our cations to stick to it, and then all our other things pass through, all our negatives and our zeros and um, whatever it may be, and that we will get our cations eluting last. Like that's very important to understand with our cation exchange column. And so making sure they understand that. Now, when we go to solve part A and we're trying to figure out what the predominant charge is, I want to know if they understand what happens when we have, so like looking at amino acid A here, what happens if we have a pH that equals our pKa, right? And so we know we're going to get that 50-50 racemic mixture when our pH equals our pKa. And so just understanding that, just looking, I'm looking to see if a student understands that. And if they don't, I would go in and explain this to them and asking them, okay, well, we have that 50-50 mixture. So what would that mean about the charges that we might see for this pKa or this side chain for this amino acid? And so I'm looking for that positive or that zero charge, which when we look at our overall charge for the amino acid, we're going to get that -2, because minus, minus, and zero is -2, or that -1, because minus, minus, plus 1 gives us a -1 charge. And then I'd go through the rest of part A with them, making sure they understand how to get the answers that you see below. And then the same thing with part B. Something I would make sure they understand with part B, because when we're looking at part B, we now have a pH of 4.5, and we're going to see which amino acids elute when. I want them to first understand that what we're looking at in part B is similar to what they will see in lab. So understand that what you're doing in class will help you in lab and lab will help you in class, because sometimes students lose that and they get behind and they don't think about it, but really what you're doing does transfer and it does help. So something you would see in lab when running chromatography is we would have that mobile phase that elutes first, and then we'll have a really big gap before we start actually seeing the real peaks of the stuff of interest. And so, like it says here, we know that peak one is something in the mobile phase. And so that's like a freebie. It's saying one, two, three, four. Now you have a 3 and 4 chance, And that's something really interesting to know about the class and something that students may not know when they're confused. So understanding that, like, hey, we're gonna have the mobile phase first. You have to have that. And so going into your exams knowing mobile phase will come first can be very helpful for students. And then understanding that what you did in part A is exactly what you're going to do in part B can be very helpful, except now instead of pH of 10, we have a pH of 4.5. And just walking the students through the same steps that we did in part A and part B and making sure they know how to transfer it, and then having them rank our amino acids into when they will elute. But overall, the way I would teach students is not by giving them answers, but helping them figure out the answers on their own. Because they attended class, they attended lab. I know this stuff, it's in there somewhere. I just gotta pry it out a little bit. And that's how I intend to help. And I really enjoyed my time being at ULA the first time, and I can't wait to do it again. Thank you so much and have a great day.